Let's look at our notes for today. We are learning about function notation. So I'm going to read this to you. Think of a function as a machine. A number goes into the machine, that's your input. The machine performs the operations requested, and then a number result comes out of the machine, which is called your output. In function notation, the expression f of x describes the operations the function machine will perform. Try one below. So this is function notation. F of x is the same thing as saying y. So I'm going to put y right here. F of x could be replaced with y. But the reason we use f of x is so that we can plug in a number for x right here. And so we'll know what operations will be performed on that x. So anytime you see f parentheses x, that's read f of x. You can have different functions. You can have g of x, h of x, s of p. You can have different functions and different variables. It doesn't always have to be x, and it doesn't always have to be f. But in this case, f is the name of the function. It's pointing at the x. This tells you that x is the input. 2x tells you what the function does. This function multiplies the input value by 2. Here is a function machine. So it's showing you 3 is going in. That is our input, which is also, this means that x equals 3. So we will perform the operation 3x minus 1 and get out a number for the output. So let's plug it in. So g of 3 equals, you're going to plug in a 3 for x. So 3 times 3 minus 1. We'll perform this operation. 3 times 3 is 9. 9 minus 1 is 8. So the output is 8. So out is 8.
How do you know to put a 3 where the x sits?
It tells me 3 goes in. 3 for the input. Yeah, it'll either tell you the input or the output. So what this means is when x equals 3, comma, y equals 8. When x equals 3, y equals 8. We plugged in the 3 for x, and we came out, after performing the operations, 8. This can also be written as a coordinate pair. Remember, our coordinate pair is an x value and a y value together. X goes first, so it's 3, 8. Where x is the 3, y is the 8. Okay, go ahead and glue this in your journal right at the top, because we are going to do some examples down at the bottom. All right, let's write the examples down on the bottom. So we have this example, f of x equals 2x. So f of x equals 2x. 2x. I don't know what I just did. Don't copy that. I think I got ahead of myself. So that is one of the functions that we'll look at. F of x equals 2x. So we are going to use f of x equals 2 of x. And then I'm going to use another function. I'm going to name it g of x equals 3x minus 1. These are our first two examples. F of x can be any. So in this case, f of x is 2x. So let's do f of 2. When you substitute in a value for x, you need to keep it in parentheses. So 2 times 2, which just equals 4. Let's do f of negative 3. This means 2 times the negative 3.
Wait, why?
Our function is 2x, so all we're doing is replacing the x value. You see the x value? We're replacing it with 2 here because x was 2. We're replacing it with negative 3 because it's f of negative 3. So 2 times negative 3 is negative 6. Okay, so let's do the g of x example now. So g of negative 5. So g of negative 5 means that x is negative 5. So we're going to substitute it in. So it'd be 3 times a negative 5 minus 1. So we can use our calculator if we want, or we can do it manually by multiplying and subtracting following order of operations. What is 3 times a negative 5?
That's negative 15.
Minus 1
Is negative 16.
Negative 16. Okay. So we're using a different function. And we're substituting in negative 5. Let's do g of 0. So g of 0 means I'm plugging in 0 for x. So 3 times 0 minus 1.
Might that be negative 1?
Yep, just equal negative 1. 3 times 0 is 0 minus 1, so that'd be negative 1. All right, let's compare f of 3 with g of, g of 4. So whenever I say compare, that means we're going to see which one's bigger, and then we write an inequality symbol between them. So let's do f of 3. What is f of 3 going to equal?
6.
6, because it's just 2 times 3, which is 6.
I'm confused. Why are you getting like the 2?
The function is f of 2. We're still using the same function.
Oh.
So all I did was 2 times whatever the x value was. In this case, the x value was 3. And then g of 4, I'm going to plug it in the g function, which is this one, 3x minus 1. So 3 times 4
12,
minus 1.
11.
Yep, so 3 times 4 is 12. 12 minus 1 is 11. There we go. So let's do f of 3 is compared to g of 4. What inequality symbol will compare these?
Greater than.
What is f of 3?
Less than.
6. Yeah, it's going to be less than.
Well, like g is greater than 6.
But that's not how I wrote it. I wrote f first.
Oh.
Shh. All right, let's do, instead of comparing this time, let's do f of negative 6 plus g of 5. So see how I'm performing an operation, f of negative 6 plus g of 5.
So would it just be negative 12 plus 14?
Yeah, so f of negative 6, what did you say f of negative 6 was?
Negative 12.
Yeah, because it's 2 times negative 6, negative 12. So this is negative 12. And then g of 5.
Is negative positive 14.
What is it?
14.
Yeah, it's positive 14. So negative 12 plus, we know that the g of 5 is positive 14. So then what does that equal?
2.
Yep, 2. Just equals 2.
Oh, it's a negative.
Okay, let's do f of negative 12 minus g of 0. So f of negative 12 is just found by multiplying 2 times the negative 12. Which is negative 24. And then g of 0
It's negative 1.
is negative 1. We found that earlier by multiplying 3 times 0 minus 1. It was up here. So now we'll plug in f of negative 12 is negative 24 minus, what is g of 0?
Negative 1.
Negative 1.
That makes negative 25, correct?
What do I do with minus a negative?
Oh, keep change.
Keep change. So it's really negative 24 plus 1. Negative 23.
Hold your breath.
All right, so I'm going to show you the Delta Math problems. We're going to do some examples on there on the next page. So go ahead and title the next page here. More function notation.
I wonder who made the word function. They put the wrong word at the beginning of it.
It is fun. What are you talking about? Okay, so let me show you The assignment, it's called function notation. So I'm going to look at some of the problems. New problem. Okay. Here's the first problem that we're going to write down. So write down g of x equals negative x minus 2. And it says find g of 1.
Is it telling us that 1 is the input?
Yes, that means that 1 is the input.
Do we try it?
Yeah, go ahead and try it.
X equals 1.
Yep, so this means x is 1. So we're going to plug in a 1 for x. So it'd be negative because the negative's there. And then 1 because 1 is what x is. Whenever I substitute it in, I want to make sure to keep that x value in parentheses. So negative 1 minus 2.
Equals 1. Negative 3.
Negative 3.
Oh, goodness.
Negative 1 minus 2. You only keep change. Well, if I keep change, it's going to keep change. It'll be like this. Negative 1 plus negative 2.
That'll still equal negative 3.
It'll equal negative 3. The only time they mark out is if it's minus a negative. But this isn't minus a negative. Okay, so negative 3 is the solution there. Let me see if I can find any. Let's do this one. F of x equals negative x plus 2. Find f negative 5. So that means I'm going to plug in a negative 5 for x. There's already a negative out front. Then I put my negative 5, my input, in parentheses still. Then plus 2. Whenever you have a negative, back to back, what happens to those? Yeah, it becomes positive. So that just means 5 plus 2
Equals
7. Okay, let me show you the second one. All right, let's look at this one. Okay. F of x equals negative x squared plus 6x plus 9. Find f of 1. So anytime you see an x value, you're going to plug in a 1 on this one. So f of x equals negative and then x squared plus 6x plus 9. So everywhere you see an x, we're going to plug in a 1. Keep your input in parentheses. So this will be negative parentheses 1 squared plus 6 times 1 plus 9. I plugged in a 1 every time that there was an x. We can put this straight into the calculator just like it is. Negative parentheses 1 parentheses squared. So remember where the squared is? Squared. Plus 6 times 1 plus 9.
Equals 14.
Sometimes I wish a calculator would show you how it got to that answer.
Yeah, I can show you how we got to that answer. You have a negative here, but you follow order of operations, which says parentheses. There's nothing to do in there. Exponents. This is just 1, so it's negative and then 1, plus 6 times 1 is 6, plus 9. What is negative 1 plus 6? 5. 5 plus 9 is 14. You're welcome. Let's see what other problems we have. Okay, write this one out. F of x equals 3x squared minus 4x. Find f negative 1. So everywhere I see an x, I'm going to plug in negative 1. 3. Remember, keep your x in parentheses when you input it. Input is in parentheses. Make sure you see the difference between negative and minus. You use the negative down here, minus for minus, negative for negative. They're different. Is that what y'all got? So equals 7. 3 and then negative 1 squared minus 4 times a negative 1. So the way that this one works out is order of operations says exponents first. So this is just negative 1 squared means negative 1 times negative 1, just positive 1. 3 times 1 is 3. And then 4, negative 4 times a negative 1 is a positive 4. This whole thing equals positive 4. 3 plus 4 equals 7. Okay, let's see if there's anything else everything else is pretty much the same. Let's look at one more, compare functions. Okay, let's look at this one. F of x equals 4x to the third power, and g of x equals 4 to the x. Compare f of 5 and g of 5.
Oh, so we're working out.
Okay, so see how this says f of x is 4x to the third, g of x is 4 to the x power? And then each one of these is f of x or g of x. We're comparing. This says f of x is greater than, f of x is less than, or f of x is equal to.
Well, obviously,
How do we
gave us the answer, so it's going to be easy.
So let's do you have this written down first? First off, make sure you have it written down.
I thought it was f of x is 4x to the third power. Why did you get 5?
Yeah, where did the 5s come from?
I got the extra.
See how it says f of 5,
All 5 down there.
g of 5?
Oh, yes, ma'am.
You're comparing them.
I can do that.
So in order to compare them, we need to find out what they are. So f of 5 means I'm going to plug in 5 for x right here. So 4, parentheses 5 to the third power. So remember with the order of operations, it says exponents first. Okay. We can put this straight into the calculator, or we can work it out by using order of operations. So 5 to the third means 5 times 5 times 5 more. Huh?
25 and 125.
125. So 4 times 125.
500.
Yeah.
Oh, right.
But if you want to put it in the calculator, that is fine to do so too. Do y'all know how to do an exponent of 3?
No.
Remember that carrot top? I don't know if any of your teachers have ever used it and said carrot top.
That's what I do. I don't do the.
Wait,
Oh,
how do
you don't?
How do you
I don't
do
do
it a different
square.
way?
I just do that.
I always put in my exponents like that.
Oh, really?
What's
There's a
that?
squared button here.
I didn't know.
Oh.
Well, that's not. That's.
Oh, that's magical.
All right, so
Too many buttons.
that does equal 500.
Besides, it's almost never square.
I'm
It's always
smart.
like to the 5 millionth power. No.
So g to the 5 means 4 raised to the 5th power. Keep that in parentheses though. So 4, then the little carrot top, then to the 5. That parentheses really doesn't make a difference though.
Oh my.
1024.
I wasn't to the answer. I wanted to make sure everybody could figure it out. Yeah, but I know.
So then how do they compare?
Less than.
So f of 5 is less than g of 5. Okay, so your assignment is on Delta Math. You're going to work out all your problems on a sheet of notebook paper. You can use the calculator to do it like this. I just need to see that you're actually plugging in and getting an answer and then writing down what your solution is. You will turn in your work from Delta Math when you're done.